Well, let's just get this out of the way. Yes, my name's LaPook. And it's like a Piaget thing. I have 2 sons, and I was the same way. When you get to 6th grade, you come home, I don't like the name LaPook, because they call you everything that you can imagine. And then I said to my sons, Daniel and Noah, I know it's hard now, but later on it'll be Pook, Pookie, you'll love it. So I thought actually it was the power of Pook. And that's why I was so happy to do this, but it turns out I was tricked into this. I happen to be a gastroenterologist, so I'm a professor of medicine at NYU Langone. I'm the chief medical correspondent for CBS News, so I do all the different venues there, including 60 Minutes and Sunday Morning and the Evening News and CBS This Morning and all radio and all that stuff. And then the reason why I was at Columbia for 37 years, every 37 years, like clockwork, I switch institutions. So 6 years ago, I came over to NYU to do the NYU Langone Empathy Project. And the Empathy Project is to use Hollywood-quality short films to try to teach clinicians in training to be more empathetic, sensitive, and competent, and to empower patients to demand that. So that's who I am. What we're going to do is we're going to go down the line. People tell you who you are, and then I'll come back to me. And as I just said to them, I'm going to throw the basketball up in the air, and then we'll have a chat. And then at 30 minutes, we'll have Q&A. So.
All right. I'm Colleen Kraft. I'm an infectious disease physician at Emory University Hospital. I also am a medical microbiologist, so I really like both the bench and translating sort of the clinical work to the clinical laboratory. I first got involved with fecal transplants. It was March of 2012. Cliff McDonald, who works at the CDC, was giving a seminar at our infectious disease seminar. He showed a paper from David Relman's lab that showed that people after getting 6 days of ciprofloxacin, healthy volunteers, it took them 6 months to get back to their normal breadth and depth of diversity in their gut microbiome. That hit me like a lightning rod. I was not expecting to feel that way during seminar. I give people 6 weeks of antibiotics for endocarditis, for different things. And so that is what started our foray at Emory into the fecal transplant world. Now, there wasn't much to do. There wasn't open biome yet, which you'll hear about next. So I actually, because I'm a clinical microbiologist, I actually mixed our stool bank and recruited all the donors and did all the screening for about 5 years. So I was very hands-on, obviously, in getting our work done. Right now, my focus went from, we performed about 300 fecal transplants at Emory, which is about mid-range to maybe low range in the healthcare systems around the United States. We have moved a little bit away from C. diff only. I hold a few INDs with the FDA to basically give poop enemas to people to eliminate their multi-drug resistant organism carriage. So these are people that get infections, they're renal transplant recipients, they get infections with these hard to treat bacteria, and we're doing a clinical trial giving them a fecal enema to see if we can get rid of that. My overall dream for poop transplant, if we can already start dreaming in this discussion, is that I hope that we have a solution that every person after they get antibiotics, we're gonna replant your gut garden. So your gut garden gets decimated by antibiotics, all these things happen, so I wanna replant after every antibiotic use. So that's my sort of dream.
Okay, and Carolyn.
Awesome. Yeah, I think I started in the fecal transplant field around the same time, but I'm the executive director of Open Biome. Before that, in 2011, my background's actually in public policy and international development. So I was at USAID when my cousin walked into the hospital in New York for routine surgery and came out with a C. diff infection. And I don't know how familiar everyone is with C. diff, but it's a pretty aggressive intestinal infection, gives you diarrhea upwards of 20 times a day, and it's pretty miserable. And most of the time you can treat it with antibiotics, but Johnny spent 18 months on about 7 rounds of vancomycin, which is a last line antibiotic, trying to beat C. diff. And every time he went off of the antibiotics, it would come back. And so we were certainly interested in figuring out what other options there were for him. And he certainly wasn't alone, because about 500,000 Americans get C. diff every year. And 1 in 5 patients will find that the infection comes back after antibiotics. And about 30,000 people die. So it's a pretty big deal. And at the time, some of this literature on the use of fecal transplants to treat C. diff was just emerging. And fecal transplants are exactly what they sound like for those who may not know. It's a sample of stool that's taken from a healthy donor, and infused into the colon of the patient. Usually it's done by colonoscopy, but it can also be done through a tube that runs from your nose into your intestines or actually through pills. And so Johnny found this literature and was like, this seems like a great option for me. And he tried to find a doctor who performed fecal transplants, and there was one guy in New York doing them at the time, a gastroenterologist named Larry Brandt, and Larry's wait list was like 6 months long, and Johnny did not think he was gonna make it. So he went out and he got a blender and an at-home enema kit, and he asked his roommate for a sample of stool, and he did the procedure himself at home. And the crazy thing is that it worked. I mean, within a day, he had his life back, but we, those of us who love him, we're looking at this thinking this can't be how we solve this problem. On the one hand,
And you never made a milkshake again.
That's
never.
Right. And you did not clean that blender out and use it again, I hope.
Mudslides has become the cocktail of choice. So what we did is we started a stool bank so that it would be a lot easier for patients like him to get access to treatment. And to date, we've sent out about 50,000 treatments to a network of about 1,200 hospitals and clinics around the country. And the other half of what we do is support clinical research in this space, because I think, as probably a lot of folks in this room are aware of, there's a lot of burgeoning interest in what else we might be able to use fecal transplantation to intervene in the microbiome to drive good clinical outcomes.
Great.
All right. So this is really fantastic, and thanks again for having me on this panel. I'm Garabet Yeretssian. I'm the director of the Crohn's disease program at the Aspen Charitable Trust.
Talk a little bit slow. So Garabet is his first name, and that went by fast. Talk just a bit slow.
Garabet. Okay, I'll do that. So Hamsley is a private foundation that is based in New York, and we have our offices also in Sioux Falls, South Dakota. It's focused on health and healthcare, and it serves populations regardless of geography, so it's global. We do focus on 2 disease areas in any geography, which are type 1 diabetes and Crohn's disease. Crohn's disease is the focus of my program. This is what I'm passionate about, and it keeps me up at night. I'm an immunologist by training. I've been working in the space of Crohn's disease, ulcerative colitis, and colorectal cancer for the past 10 plus years. And before my time at Hamsley, I was in academia doing basic research, leading sort of research projects, understanding how these microbes and bacteria interact with the host and shape the immune system to protect us from infections mainly, but also to understand how the immune system functions during disease, such as Crohn's disease. So we've been investing for the past 10 years since we started grant making in the space to focus on precision medicine for Crohn's disease, to really deliver and enable to give the right treatment to the right patients at the right time. And it's been really a journey for us to understand what are some of the challenges that Crohn's patients suffer from. And Crohn's, just to give you a quick overview of what it is a GI, so gastrointestinal disease that affects any area of the gut from the mouth to the anus or rectum. And it's specifically, or the most prevalent area where it affects is the small intestine and the colon. So we do have lots of challenges in the space. Some are related to diagnosis because we rely on colonoscopies or endoscopies to reach those areas and eventually identify whether a patient has the disease and has an inflammation. And for the past 50 plus years, this is what we've been using. And we know that it's invasive. It's not available for everyone. If we think about it globally, where the disease is rising dramatically with the environmental changes and the presentation just earlier on the deep dive that Sarah was moderating was extremely important, because it shows that how diversity of microbes is essential for us to sort of shape our immune system and eventually fight diseases like Crohn's. Other areas that we've been focusing on is prevention. We've invested in dietary interventions to shape the microbiome and deal with these environmental changes. Lots of therapeutic focuses where this morning Aviv Regev presented about the human cell atlas. So we're building the gut cell atlas to understand every single cell in the gut and how these cells talk to each other and eventually how they talk to the microbes. And in the same space, our interest in the fecal transplants stems from a lot of the work that has been done by OpenBiome and many others in academia, where we actually want to see whether we can use it to treat Crohn's patients. And again, not every Crohn's patient eventually will respond to a fecal transplantation. However, they will be sort of at least a category of patients or a class of patients that we've been studying for many, many years now that hopefully will respond. So one other thing that is very, very important is really to manage disease and cope with it, because it's a lifetime disease. Once you have it, there's no cure. We aspire, and this is what my dream is eventually to find a cure one day, or cures for these different individuals. And that's why precisely targeting each patient and helping them to get the best treatment, I think that's what we're hoping for.
Thanks. So as a gastroenterologist, let me set the stage for you a little bit. I'm going to assume that there's somebody here who doesn't know anything about this, okay? So the gut microbiome, trillions of bacteria that are in our guts, hundreds of species, maybe more than that, and they're all interacting in ways that we are just now beginning to understand. They're in a balance. It's turning out that the gut microbiome is important for, you name it, immune function, autoimmune disease has been linked to it. Even heart disease has been linked to the way certain things are processed in the gut. Depression, because the gut has been called by Mike Gershon, one of my early professors, the second brain. So we know the gut talks to the brain talks to the gut. You could go on and on and on about the things that are involved with the microbiome. Obesity, it looks like Jeff Gordon at St. Louis did some people consider the godfather of the microbiome, did some fascinating studies where he took the stool from thin mice and he transplanted them into obese mice, and the obese mice in certain settings became thin, given a certain diet, and vice versa. So in that context, we know that the microbiome is very, very powerful. In terms of C. diff, I've done colonoscopies on people who have C. diff colitis. So it's C. difficile is one of the bugs that's in there. It's usually in there in a small amount. When you give antibiotics, you upset the balance. The C. diff grows up. It makes two different types of toxins. And you can cause actually ulceration of the lining of the colon. And people can die. I've had patients lose their entire colons from it. So this is no small thing. You heard about the statistics. So it's a very big deal. All of that is framing the big question, which I want to now throw up the basketball to. So you can't have your cake and eat it too, right? You can't on the one hand, we're saying that the microbiome is unbelievably powerful, and changing it can do really powerful things. On the other hand, we're now as a treatment giving stool that has how many different species of bacteria in it, in what concentration. When you think about the FDA approving a drug, it takes years to get one ingredient so that you can isolate it and you figure out what it's doing. It's one of the reasons why herbs, are considered food, because my gosh, how could you ever even study it? There's so many different things in it. That's what we hear from the FDA. So I want to throw to you, oh yeah, everybody turn off your phones, as I'm hearing the phone. I want to throw to you, is it of concern as you're doing this, especially in the early days, when you're putting stool in a blender, what are some of the potential unintended consequences of this type of treatment?
Want me to start?
Yeah.
Okay. So I think one of the things that, if you haven't heard, because you don't live in the microbiome realm like we do, there was a death that was attributed to a fecal transplant, that a patient received a multi-drug resistant organism through a fecal transplant. We don't really know, I don't know any of the other details.
And the patient was
clinically.
immunocompromised, I believe.
Yes,
right?
and that's an important thing. So I think as we are doing more of these, like Carolyn said, they've sent out 50,000 doses. We are still learning about right patient, right dose, right timing. I think this also becomes really important in Crohn's. Is the timing the same for every Crohn's patient? And so that is an unintended consequence that the FDA has really been waiting for,
Right.
because they have had concerns for a long time that this is not a standard, right? Would we all agree poop is not a standard thing? So even blood products, et cetera, are a little bit more standardized than the gut microbiome.
So how do you address that as a scientist? How do you even think about designing the studies that look at the short-term, medium-term, and long-term effects of giving all of these different species?
Yeah, so as somebody that was the only one doing the work at a much smaller scale than Open Biome, so I want to hear from Carolyn. I had very standardized donors, so we had people that sort of met all the FDA criteria, the draft criteria, that the physician or the recipient would know the donor. I was Facebook friends with my donors, so I kind of knew their behavior. They were actually pathology residents. You can Google one of them, poor guy, he did an interview and then he got a lot of emails about his poop. Am I gonna get Dr. Johnson's poop? We'll see. So I think one of the things we've tried to do is just know the donors, which is what most people do, and know their lifestyle, no chronic diseases, no drugs of any kind, prescription or non-prescription, low risk lifestyle, all that kind of stuff. They are thin, so we have a BMI requirement for our donors. I also, because I have 3 children, I don't let people with school-age children donate because there's all sorts of viruses and things. That's just a Colleen Kraft rule. That's not probably you never read that anywhere. So those are the things that I sort of think about when we're putting it together. So our current study that we're doing with the renal transplant recipients and the fecal enemas, we have 1 donor we're using. So we're trying to control it to be just sort of 1 population to see if that has benefit.
So, and I'll ask this question of you. Yeah, of course, infections, you don't want to have infections, but I'm talking about something much more subtle than that.
Yeah.
I'm talking about the fact that 27 years from now, somebody is going to discover that species ends up causing, Sjogren's syndrome down the line, or some other autoimmune problem, or cancer, or whatever, because we're saying it's powerful. It's powerful enough to kill you if it's messed up, and we're just now scraping the top of the knowledge of what the microbiome does and how everything interacts. And yet, and of course in people who have life-threatening illness, we're willing to take that risk-benefit. But
Sure.
How are you thinking about, forget about the fact we're going to say it's not going to have a virus and it's not going to, but aside from that, just the normal, everybody's microbiome is different. It's like a unique snowflake, right? So how do you know what the effective, and are you looking for that in a controlled way prospectively going forward?
Right, yeah.
And how are you measuring people's you give them a transplant, are you measuring their stool and tracking what happens to their microbiome, whether it engrafts, whether it doesn't engraft? There's research, I'm sure you know from Israel, showing that, that the research that's being done where you take the stool and you look for microbiome, well, that may not be the total best way to do it, because if you then biopsy, they actually did colonoscopies and upper endoscopies and biopsied the small intestine and the colon, and it turned out that what you see that comes out may not reflect what's actually happening, that some people it engrafts, meaning it stays and it grows. Other people it goes straight through. In some people, if you give probiotics at the same time as in certain types of responders, after antibiotics, it actually prolongs the time that it takes for the microbiome to return to normal. So there's a lot of these unknowns, and you're given these trillions of bacteria. So I'm going to go back to that, like what you're actually doing to study that.
Yeah. And it's part of what's exciting about being at the beginning of a really kind of emerging field. But I guess there's 2 parts of my answer to your question. The first is when we look at our donors, how do we think about who gets to be a donor? And we actually exclude 97% of people who apply to be stool donors to Open Biome. And part of what we're looking for is known, risk of pathogenic transmission. So anything that could exclude you as a blood donor, you're eliminated for. Also things that we know could be transmitted through stool, you're eliminated for. So we've always screened for the bacteria that caused this death in this patient. We've always screened for it. We know that in that case, the donor who was used wasn't screened for that bacteria, and we don't know who it was. We don't really know kind of like what the circumstances of that study were. But on top of those things, we also exclude people who have any of the diseases that appear to be associated with the microbiome. And we have no idea, we don't know causality yet. We don't know if you can cure it. We don't know if you can cause it. And so out of an abundance of caution, we eliminate those people. But then getting to your question, how do we start answering, causality?
Or just even study it, like what parameters?
Or even study it, yeah. One of the efforts that I am most excited about is being led by the American Gastro Association, the American Gastroenterological Association, and they are prospectively registering 4,000 patients who are FMT recipients to enroll in a 10-year registry. So they'll follow these patients for 10 years. And most of them are getting fecal transplantation for C. diff because that's mostly how it's being done now. But they're also participants in studies that are looking at it for other disease indications. I think at least 1,000 of those patients will be sampled at least before and after their fecal transplant. And at least for those patients who get FMT from us, we're supplying samples
Just
from the donors.
FMT, fecal microbiome transplant.
Sorry,
right?
thank
No,
you.
That's all right.
Yeah.
That's my job.
So we will start to understand, we will start to be able to look at long-term effects. We will start to be able to tease apart some of these questions around, what are we giving? And then across the 40 different studies that we've supported, that's always part of the question that they're asking. Now, they don't have the funds to follow patients for 10 years, but they are looking sort of at least over the period of time in their studies, how can they connect kind of what was going with the patient before and after FMT to the donor. And that, I think, is just starting to help us answer some of those questions.
Garabet?
Do you mind if I will?
No, yeah, no. And by the way,
Yes.
pretend I'm not here. The best discussions that I've ever moderated, I don't say a word. So if the three of you pretend you were in a bar and you had a few drinks and you're talking about this and you interrupt each other, but wait a second, what are you talking about? So really, we want to, and they can be the fly on the wall right now.
So we actually took a sort of a new approach to look into fecal transplants by doing, or at least investing, in autologous transplants. And autologous means that you're taking the stool or the poop from yourself and giving it to yourself. So the idea is actually, hopefully in the future, to be able to bank your stool samples when you are healthy, and then when you need it in the future, after an antibiotic intervention or after C. diff infection or whatever, you can use that stool sample in the future. So we're doing tests in mice. We're gonna try to replicate it in Crohn's patients, hopefully. At this point, pediatric, we can really control, because parents will be controlling how the stool samples are collected. And I think this is sort of a new approach that we're just exploring and hopefully will be successful. And coming back to how to sort of compare what we have in the stool and what stays or sticks to the barrier of the gut. Unfortunately, until very recently, we didn't have the tools to really see those microbes that were in close interaction or in close connection with the gut barrier. So by taking a biopsy, we weren't able to see if there were any microbes. But now that the technology allows us to do that, actually moving forward for any longitudinal study that at least Helmsley is funding, we're looking into biopsy-associated microbes,
right.
Because that is those are the microbes actually that are driving diseases or eventually maintaining the balance or health in the system. So I just want to...
No, and I think that's going to be a really important point. Mm-hmm. And the banking your own stool, I mean, it may sound icky, right? I mean, all of this sounds icky, let's be honest. But it's fascinating, and it made me think, the first time I heard about that, one of the theories of the appendix, so your appendix is in your right lower quadrant, and it's like a little worm-like little protrusion, and it actually connects with the colon, and then it sticks out, and you can get appendicitis. When it gets inflamed, you got to get it out or get antibiotics. And people have wondered for years, right? What's that thing doing? And one theory I read about, which is so interesting, was that infectious diarrhea was so prevalent back in the good old days that you would clean out your colon, and this was a reservoir of your stool, just doing just what he's saying, except for it was just sitting there because it was sort of stuck in there. And then once you were well, it came out and repopulated your gut. So you've probably heard about that. I think that is just a fascinating, we're trying to reinvent, just take a look at the amazing human body. And
there's more and more studies actually to look at the stool composition and diversity in that area, because you might miss some species that are not staying, but they're really housed there or stay there. So hopefully these studies will help us understand better the microbiome that is staying locally in the gut.
All right, so we know that there's pretty much very little doubt right now that fecal transplants are very helpful for people with C. diff colitis, who don't respond to antibiotics, and you have to have some failure of oral antibiotics, Flagyl, vancomycin, they don't work, you're still sick, you don't need a blender. Let's move away from that for now and start looking at some of the other applications. And of course, who wouldn't want to take advantage of that thin stool idea, that if you just somehow get, and by the way, the poop pill makes it a little easier. You know, you can put the bacteria that are in stool and encode them with a capsule or a pill and just make it easier so you don't have to have a colonoscopy. With colonoscopy, you actually get a colonoscopy and then you squirt it in, and then it's sort of a big deal to do that. What are some of the applications you're looking at that aren't so obvious? I know it's been looked at colitis. Results so-so, not perfect yet with colitis. There's been some ups and downs. Fecal transplant for C. diff, much more, overwhelmingly successful. But what are some of the other things that we should all know about? What's coming down? What's next season? What are
Which spaces to watch? Yeah.
Yeah.
Do you want to start? I have.
Go for it.
So we're, like I explained in my intro, we're doing it for multi-drug resistant organisms. So
Right,
again,
that's
it's that gut garden that gets disrupted with antibiotics, and then these weeds, is what I call them, grow up in the gut garden. But we're giving weed killer all the time. We're not replanting that garden. And so I think two areas that we're working on are the fecal enemas to eliminate, because it's a very similar mechanism to C. diff, right? C. diff is the same thing, but instead of C. diff, you're getting extended spectrum beta-lactamase producing E. coli or very drug-resistant bacteria. And so I think it's going to prove to work in that. We have 2 prospective studies that we're doing. We've enrolled 6 people. There's people that are farther along in it than we are that have more patients. But I think the results are going to look similar because the disruption of it is similar.
And that will be a very, very big deal, because as somebody who's done work in hospitals and come across these resistant organisms, we all know that we're running out of antibiotics. There are some bugs we cannot treat right now. This would be just thinking outside of the box, a new way to do it. And wouldn't it be amazing if we did have those stores of our own stool that we could just,
Right.
bring it back in? That would be amazing. That would be amazing. What's your company looking at?
Yeah, I think the area of antibiotic resistance and seeing if you can help there is huge. And in addition to some of the MDRs that we see commonly here, open biome
MDR, multi-drug resistant organisms.
Antibiotic resistant bacteria, I think, is the more normal way of saying it. But I think, we're looking at a study in typhoid. Typhoid is caused by Salmonella typhi, which is only found in human hosts. And so if you want to think about eradicating typhoid, one of the ways you can do it is by getting it out of people who carry Salmonella typhi around.
And I'm going to interrupt you just to explain that with Salmonella, one of the problems is we actually don't give antibiotics for it. Usually we just want you to clear it yourself because you can prolong the carrier state. And sometimes, as she's implying, you just keep having the Salmonella, and then you have it chronically, and it's a real problem, like typhoid Mary. Right?
Exactly.
Okay.
And I think one of the other studies that I'm really excited about is right out of Jeff Gordon's research that you mentioned at the top. So in addition to studying obesity, one of the other things that Jeff Gordon's lab looked at is the other end of the spectrum, severe acute malnutrition. And there are children with severe acute malnutrition. About a third of kids don't respond to standard of care nutritional therapy and antibiotics, which is usually how you treat severe acute malnutrition. And Jeff, being brilliant, found a bunch of Malawian twins where one twin was healthy and the other was severely malnourished. Took samples of stool from those kids, fed them to mice, and the mice developed. One of the mice was healthy, one of the mice was malnourished, and then he co-housed those mice. And the really nice thing about mice is they're coprophagic, which is a fancy way of saying they eat each other's poop, which is a great FMT-style intervention.
But it did lead to us getting rid of one of our dogs. But anyway, I digress.
Yes. Yeah, animals eat each other's poop all the time, and I don't know. Take what you want.
But
from
the
that, I guess.
dog
Put a
did
meat
fine.
tenderizer
There was
on
somebody who wanted the dog. I don't want you to think. No dogs were harmed in this. So
Yeah,
Meat
and-
tenderizer, that's what you're supposed to put on.
we did. It didn't work. We didn't. Spices didn't work. Nothing. Anyway,
Yeah.
there was a reason why it didn't work in our household. But anyway, continue.
Well, this is a happy story for the mice too, because
Yeah.
the mice that had been severely malnourished or showed the hallmarks of severe acute malnutrition recovered when they were kind of exposed to or at least co-housed with healthy mice. And so that, in addition to a bunch of epidemiological data, to us suggests that it was maybe time to start trying this in kids. And so we're working with a really great team at the University of Cape Town to see whether or not fecal transplant can help children who don't respond to standard therapy for malnutrition to start to recover. So that's what I'm excited about. But I think there's such a diversity. I mean, I think looking across kind of the spectrum of studies that we've been supporting, there's just a burgeoning of interest across autoimmune disease and cancer and boosting response to cancer immunotherapy. I think that's a really interesting avenue. As you mentioned, the gut-brain axis is a really active area for research.
And heart disease, right? What's the LMAO? There's a compound if you have in red meat, and if when they got rid of the bacteria, certain bacteria, you gave antibiotics, you didn't form the compound that got absorbed that increased heart disease. I'm forgetting what the initials are.
I haven't worked at it at all, and so I don't know enough of the literature to
anyway,
speak
so,
intelligently on whether or not it's
which
real.
is why I come back to we're given these, these trillions of bacteria, and maybe we're doing something bad with this and good with that, and
Although I will say that one thing we'll say about that is if we're carpet bombing the microbiome all the time with antibiotics, and we want to talk about the long-term interventions of some things that we already know we're doing in the microbiome, I think whether or not some of the stuff that we're working on now has long-term effects is a really important research question, as is kind of looking at what we're already kind of using as part of the standard medical toolkit to intervene in the microbiome.
Yeah, I just hope that people are really doing long-term. I know it costs money, and there's nothing in it for you now, and we know what drives companies, bottom line profit, but I think it's a really important research question that has to be answered.
Totally.
So anyway,
And we've been doing
that's why
it
I keep harping on it.
kind of in a retrospective. So we've called up, we published on this where we called all of our recipients and asked them if they got certain new diseases, if they're on new medications, if they had any complications. And so we have published that, but it's smallish. I mean, it's not 50,000, it's about 300.
Did you bring them back and measure the microbiome again?
No.
Wouldn't that be interesting?
Oh, yeah, definitely.
And here's $20.
I did want to also
Expensive to do
mention
that.
another thing that we're looking at was urinary tract infections. People forget that when you get urinary tract infections, it comes from your intestine. That's where the bacteria are coming from. And so I have this sense that there are bacteria that are selected for when you get chronic antibiotics for urinary tract infections that are more tropic or want to go into your bladder. And so we published a couple case reports on individuals that got fecal transplant because, of course, they were on chronic antibiotics for urinary tract infections. Inevitably, they're going to get C. diff. And after they got their FMT, they no longer had urinary tract infections. So anecdotal, but we are working to start that clinical trial as well.
So one thing we're exploring actually to bypass the transplant or fecal transplant with trillions of bacteria is really to, at least for a specific disease like Crohn's, to see what are the bacteria actually that are present during the disease, and what are the ones that will compete with them to move them out. So creating a group or a consortium, we call them, of bacteria, maybe 10 or 50 bacteria instead of trillions, and putting those in a pill and giving them to patients might bypass sort of side effects or long-term effects that we might see. At least we know that those few bacteria are beneficial for the host. So maybe those are things to explore in the future for any disease.
I want to go to questions before. I just want to sort of sum up. So I graduated medical school in 1980, 76 to 80. And in medical school, aside from Michael Gershon's The Second Brain, which was brilliant and prescient, I was taught, yes, there was some bacteria in the small intestine that are important. They could make for certain vitamins B12, and it was important for certain little this and a little of that. But the colon, it did two things. It was a store for stool, and it got back the water. And when you think about where we have come from that, I mean, it is really unbelievable, and we are a tick in the evolutionary clock right now. I mean, 1980 to now, microsecond in evolution. And you have to understand what a revolutionary idea this is and how explosively interesting it is. Explosively may be a bad word to use.
There's always a poop joke that you can make.
But when I talk to the medical students, I say when you watch a movie and there's this important moment coming on or a scary moment coming on, we're all so smart. We all know it. How do we know it? There's a close-up and the music changes. Look how smart we are. Something scary is about to happen. In life, there's no close-up and there's no change. There's no music change. So you have to sort of have the soundtrack in your own head. You have to you're controlling the zoom. And I think it's a good time for us to sort of take stock of this moment, and I think I can do it as well, fairly well, because of just how long I've been doing this and being a gastroenterologist. This is one of those moments where the music is changing and the close-up is happening. This is a big deal, and we are at the very, very beginning of it. And if you've been in medicine for 5 years and you have any degree of cockiness left, you are in the wrong profession, and which is why my questions have been, for a large part, been around what's the safety, what don't we know. I've been through enough of the fads where we knew that giving vitamin B12 was going to decrease heart disease, and we knew that didn't happen. We knew that vitamin E was going to decrease prostate cancer. Oh, it increases it. We knew that hormones were good for women. Oh, they could cause, the progesterone causes breast cancer. And heart disease. And so I'm very humble when it comes to. I'm excited about them, these new things, but I really do think we need to maybe have a few more checks and balances in place as we go forward. So with that, we're going to go to Q&A, and who has a mic? There we go. The first person, this guy right over here, Bill.
Thank you very much. The gold standard for fecal transplants is still a colonoscopy. You mentioned that your hope would potentially be to give enemas to people after antibiotics. What's the efficacy of fecal enemas and also the poop pill or crapsule?
Nice.
Follow-up, just one more question. Where did the stool sample come from? I did read about the death of the person who had the fecal transplant. I'm wondering, did it come from Open Biome? Thank you very much. Or someplace else? Thank you.
So the order of efficacy, sort of in my mind. So I actually want to give people poop pills, and nobody wants a fecal enema, right? I mean, like for long term. I want us to all replant our gut gardens, hopefully with some sort of, yeah. Or I like to say a probiotic that actually works, because I think sorry, if there's any probiotic lobbyists here, I apologize in advance. But so I think something that actually can replant your garden. Colonoscopy is most efficacious, followed by sort of fecal enema. There have been some comparison studies, these are usually pretty small, that the crapsules are as good as a fecal enema, or sometimes as good as colonoscopy, depending on how many that you're giving. If you're giving the same volume that you give by colonoscopy in the crapsule, if you're taking 30 pills, or 30 pills in a day, that kind of thing. But some, so all these companies are working on lyophilizing, doing their own bacterial consortia.
Lyophilizing is drying something, freeze drying it, like flash drying.
Yes.
So it's kind of solid, little.
So I think that I think we're going to get better at knowing what we need to give back, and so then we can give it via pill. So.
Cool. Why don't we go over here, and then we'll come over to here, to Mia. First Kristen, then Mia.
Hi, thank you. That was an amazing talk, and I'm super excited to see how FMT is evolving. I have my own story to share.
Oh.
3 years ago, I had a ESBL E. coli UTI that was incurable. I was actually septic, and I almost passed away. In the process, I infected my husband, too. So both of us were ESBL E. coli UTI carriers. I'm a dermatologist from San Diego. I did my own research. I found that there were 2 case reports of renal transplant patients who had gotten successful FMTs. So I went to my hospital and I said, I know this isn't normal and you normally do this for C. diff, but why not try it? Obviously it comes from your colon. Why can't we try this? I lobbied the IRB, I lobbied my hospital, I lobbied Open Biome and the FDA. They all approved it. I got my first colonoscopy FMT in July. It did not work. I did it again in September, and it worked. And I've been free of UTIs for 4 years, and I've not had a single recurrence
That's
of
great.
anything MDRO related.
It's wonderful.
My husband's totally clear, too. And interestingly, we got our FMTs on the same days, just to make sure we weren't passing it back and forth.
who drove you home?
Ping-ponging it.
My only, and this is what, I'm so excited to hear that you're looking into UTIs, because it's such an obvious application. And it shouldn't be that hard for a patient to get an FMT for something that's so safe. I mean, I know there was this one case report, but if you screen the FMT, there shouldn't be a problem. And, my only risk factor was that I had chronic sinusitis and was on antibiotics since I was 6 years old. I had 3 C. diff occurrences before then. and none of which I used an FMT for. But when you have a UTI that's not responsive to IV antibiotics for 2 years, I had a PICC line, full-time practice, 3 boys at home, trying to survive, and I wasn't. And it was solved with a simple FMT. It's like, it's so obvious. You know, I just wish more people would do it.
There you go. Okay, good story.
Thanks for sharing.
Mia, wait. I promised Mia, and then we'll go back. Then we'll go back to.
I'm actually interested in hearing what you all are most excited about. So some of the like dreamy stuff. I mean, you talked about replanting our garden, but I want to hear like the stuff that like is on the horizon that you're really excited about from all three of you.
I'll let you start, Carol.
Yeah, I mean, I think, oh gosh, there's, because we're at the beginning of all this amazing research, it's really exciting to start to wonder about kind of like what are the underlying mechanisms, what are the underlying functions of the bacteria that seem to be associated with like really important and fundamental aspects of our health. And so part of me is just interested in like doing everything I can to make it possible for all the brilliant minds in the world who want to work on this to be doing it as fast as they can so that we start to really understand it better. But I think to piggyback off of Colleen's concept, I think one of the things that I'd really like to understand is, is the microbiome as important as we think for the development and early childhood development and for the prevention of kind of long-term diseases that we have come to think of as associated with diseases of modernity. And like, is there something that we should be doing before birth and in the first few months to years of life to really help make sure that if that's when our body is learning to understand self versus other, friend versus foe, and to start to cultivate kind of this community of microbes in our guts that will carry with us through our lives, what is it that we should be doing in kids to make sure that they're on the right track?
If there were things that you didn't, I know you both mentioned about things on the horizon, so if there was something that you didn't mention and you want to mention it, fine, otherwise we'll.
I think the thing that I'm interested in is the interplay of our gut microbiome with our medications, and I think we kind of alluded to that a little bit, but there's actually been some studies that if you take antibiotics and get a vaccine, it's that you're actually less responsive to the vaccine than if you didn't take antibiotics, and so that clearly, I mean, of course, everything when you're looking for it looks clear, right? But that to me suggests that your gut bugs are like eating up your, are very, like the immunology aspect is a big deal in the gut. And then also we looked for, in our renal transplant recipients, we looked to see if they were, after they got FMT, if they like chewed up their immunosuppressant medicine faster. So those are the kind of things I think are exciting. But I really still like my dream of anybody that has like chronic sinusitis, for instance, that you actually after every course or during the course, that's actually one of the things we're proposing right now, that you're going to get basically microbiome restoration as you go or right after as like a chaser.
And by the way, if you take antibiotics, well known, you take antibiotics and you're taking Coumadin, which is a blood thinner, the bacteria go down, bacteria make vitamin K, which helps clot the blood, and so suddenly your pro time, your INR, it goes up, which means that your blood is thinner than it should be. So we know about medications and bacteria, and that's just like the simplest of things. And think about all the stuff we don't know. Did you have something you wanted to add?
Yes. One thing we're excited about is actually preventing diseases like Crohn's, sort of inflammatory and autoimmune diseases in the future, especially starting really earlier on in infants. Because if fecal transplants are safe and in the future we're going to be using them, I think intervening in individuals who are predisposed genetically, because we're doing more and more genetic studies to at least screen everyone and know whether they're predisposed or not. If we can intervene at that time and have them maintain that microbiome for their lifetime, I think we're going to probably cure diseases, not only Crohn's, but many others.
What about yeast? The yeast don't get no respect, right? Where we talk about the bacteria, right? I mean, but they're in there. We know it. Anybody who's ever had a half a bagel and go, oh, so we know there's yeast in there and they're doing stuff. That's not perfectly well studied. I mean, I know there's a whole thing, and you need to be taking. Some people feel horrible, and there's a whole bunch of people who give anti-yeast medications. They feel better, but Are you looking at that at all?
Oh, that's such a good question. No, if we think we don't know anything about the microbiome or like the
Bacteria,
bacterial
right.
part of the microbiome, I think we know even less about like the virome, the
virome,
fungum, and like
and the others.
phage. What are they doing? I don't know.
Right.
But so I think I think you're right to push us to start asking those questions urgently because they could be a huge critical piece that we don't understand, and that's why like there's this really interesting debate, I think, amongst clinical researchers right now over the kind of like, should we be trying to reverse engineer specifically what's working and have these very well-characterized compositions of bacteria most of the time for treating disease, or should we assume that we need the kitchen sink and it's going to be a lot harder to replicate kind of what you'd find just by doing something a lot more raw.
Cool. I think we have time for 2 quick more questions. So who has the, go over there in the back, over there.
So, I've had gut issues for forever. So that's my history. So I've done so many things. I used to say, I'm yeast clear for an hour, And I've called the University of Colorado when I read about what you guys are talking about. And, of course, they diss me. And so I wonder, people like myself, how far do we have to go? Do I have to get to Crohn's before I can find some way to get some help?
I think we're going to get to you, I promise. So I think the FDA is really stringent, and they're watching closely. And so, I get emails from you, people like you, every couple days. And I think that we want to try to make sure that we're doing things appropriately, that we're doing them under good guidance. But one of the things, I'm working with a nutritionist right now, trying to think about, I hope that one of the basic things that comes from this, I think we're all on the same page here, is that we have a better understanding of maybe how our diet affects, our gut. And so I think there will be, as some of this basic science knowledge or very investigational knowledge happens, I think there's also an overtone of nutrition and sort of, how we feed our gut bacteria.
Prebiotics.
And I do think that, yeah, exactly. And so I do think that is coming. It's just that it's super easy to replant a gut garden in someone with C. diff. And so it's got a clear indication there. When we start doing it to people with all sorts of different issues, then we end up having people that could have side effects, and then it'll kind of make the whole thing fall apart. And so I think we're just trying to be careful so we know we're doing the right thing in people and for people.
And what could side effects look like?
I'm gonna pass it on to, no follow-up question right now, because we just have time for one more. And I want to acknowledge how wonderful that answer was, that first line. We're going to get to you. I just think was just such a lovely line, and empathetic and terrific. So one last question, then we got to go.
I have a little bit of an off-the-wall question, but I'm wondering if anybody has explored Ayurvedic medicine, because they are totally, and have been for thousands of years, involved in the gut, in poop. They talk about drinking their own urine, eating their own poop, really focusing on the whole microbiome. Does Western medicine give any thought to this long, long history of focusing on that?
Everyone's looking at me. I don't know. We haven't explored at all this this avenue, but I don't know if you.
Yeah, so the fecal transplants in general have been around since like very early first, second century. There's like some writings in Chinese medicine. So I do feel like I will say I think it's funny that you view what we're doing as Western medicine, because I feel like we're pretty on the fringe, giving people poop. I used to joke about it in residency that like, oh my gosh, poop transplants, and then I didn't know I would be doing them a lot.
What goes around comes around.
Exactly. I have a Lego set that my kids made me of a fecal transplant Lego set.
Oh gosh.
So I think that we are definitely, have I specifically looked at Ayurvedic medicine? No, but we're definitely sort of in that realm, that basically is looking at holistic medicine, so.
And we'll end up with just saying, so I think we're very well served to have integrative medicine, that kind of philosophy, looking everywhere, Chinese medicine, Ayurvedic medicine, you name it, and try to incorporate those. And I think anybody doing any kind of new thing should be always looking at history and saying, what's there, what can I learn for it, and how can I move it forward? I really want to thank the three of you for a terrific discussion, and thank you, everybody.
Thank you.